Yeah, good morning, everyone. So let's start the session and hope I'm audible to the online audience also.
Yes, sir. Yes, sir.
Okay. Thank you. Yeah. Okay, right. So I'm Gopinath. Right. So I'm Gopinath and I'm part of the RISE group here, the cybersecurity group in CLAC Bangalore. And this session, which is on detection of algorithmically generated domain names. In short, they call it as DGA. Will be presented by me and Mr. Chanakya, the colleague of mine. Okay, right. So this is the outline of the session. We'll try to understand what is domain name. Of course, we had a good introduction in the previous session where we understood what exactly is the domain name, what is the DNS protocol, working of DNS protocol, what is plain text, and what is secure and privacy in DNS ecosystem. All these were understood in the previous session. But we'll start again in this because there are a few who may not be, who may be very new to this. So we'll understand what is domain name as the first part. And then we'll have a look at understanding the DNS ecosystem. And then we'll understand how a DNS query, what actually is a domain name and how a DNS query gets resolved. And then we'll understand domain generation algorithms, DGA. And then we'll understand the harmful effects of DGA. What are the harmful things which are associated with the DGA? And then we'll try to understand the working of a DGA in the DNS ecosystem. We understood the DGA and then how a DGA works in a DNS ecosystem. That has to be understood. And we have done some research on DGA and by extracting some features related to the DGA, domain generation algorithms, and we have detection approaches for that. That will be the discussion point towards the end of the session. Okay, right. So, right. So, what exactly is a domain name? This is our portal. This is our website. coednssecurity.in is our portal, our website, publicly available. And of course, we have many tools and our work, most of our work is listed there on the portal. We keep updating the portal on regular intervals. So this part actually is called the domain name. This part actually is called the domain name, the block part. Okay, the remaining is just the URL, and you have the path and the resource which you finally reach out to, right? So this is the domain name. So the DGA speaks about the randomness in generating this domain. Okay, that is the randomness associated with generation of that domain name, mathematically generating that domain. Okay, so that is what is a DGA. Hope the message is clear that URL is different and a part of the URL, the most important part of the URL to identify a machine in the internet ecosystem is what is the domain, right? So this is the name of a machine in the complete internet ecosystem. And you have asked for this resource, which is residing on this machine. So when you try to hit this URL on your browser, the request first reaches this machine and then it traverses to this file to retrieve it for you, right? So that is the way it works, to make it simple. So DNS ecosystem, if I put the whole Ramayana in one line, it is like you give a domain name and you get the translated IP address of that, because internet works using IP addresses. Internet can't understand domain names, right? So internet works using IP addresses. So the name is given for the human convenience. Man has to, people have to remember the domain name which they want to visit. So this is for human convenience that we have a domain name. But finally, internet works using IP addresses. So this IP address has to get translated into its corresponding IP address. This domain name has to get translated into its corresponding IP address, and that is what a DNS ecosystem in a single line it does. Okay, there are many other related things that happen in the DNS ecosystem. A few of the things we'll be covering as part of this session, but the primary work is this translation of a domain name into IP address. Okay, let's try to understand DNS ecosystem. First is the domain registration. Okay, let's say that we don't have a portal coidnssecurity.in registered in the DNS ecosystem. How do we get that registered and make it available on the internet ecosystem, right? So that is what is the first step. So I want to register a domain name coidnssecurity.in, right? So first registration process, I am the registrant. I want to register my domain name coidnssecurity.in has to be registered, right? So I approach one of the registrars. There are many registrars in the market. You know that. Nixie also operates on the .in registry, National Internet Exchange of India. They operate the .in registry. So coidnssecurity.in is actually registered with the .in registry because you have .in at the end of it, right? Which is operated by the Nixie. I approach the registrars, those who have the access and those who have the means of verifying whether this domain name is already present in the ecosystem or not. Right? That has to be verified because the internet can't be having duplicate names, right? The names have to be unique. So the registrant wanting to register coidnssecurity.in approaches the registrar, and I register my domain name. Ask for registration of my domain name with the registrar. There are many registrars around. So the registrars will check for the availability of the domain name, and if it is available, they'll go ahead and take some charges for that. There are various resellers starting from 200 rupees, 300 rupees per annually, or 500 rupees annually, or 1,500 rupees annually, depending on the service that they give, right? So they'll go ahead and register the domain name, which is coidnssecurity.in. Okay, so what my requirement is that I'll have to identify a machine where I can host the contents of my coidnssecurity.in, and I assign a public IP address for that. I need to purchase a public IP address and assign that IP address to that machine on which I have hosted my coidnssecurity.in, right? Okay. So once that hosting is done, if this registration happens, it's go live, right? The domain name or the website coidnssecurity.in is available for the audience to access on internet, right? So these registrars are the people who have access to the complete database. They can check for the availability and they can register the domain with the database. Okay, this is called the registry database. It is the registry. Like there are few people who are in the who have passed through the 1990s or 1980s. I hope you recollect the telephone directory book, right? As similar as this registry, it's like a telephone directory book where you map a domain name with the IP address, corresponding IP address, and that is stored in this database, right? So this is the registration part. Once this registration is done, it is live and is available for the internet audience to access it, right? So now, how does the domain get resolved? A person wanting to access coidnssecurity.in, how does it get resolved? A user visits coidnssecurity.in. I hope it's visible. Okay, all right. Right. So the first access to any domain name will end up at the recursive resolvers. Okay, at the closest recursive resolvers, and which recursive resolver is going to be contacted will depend on the service provider we are connected with, right? We have several service providers starting from BSNL and MTNL. So depending on the service provider, the closest recursive resolver will be accessed for knowing the IP address of the website coidnssecurity.in. Okay, right? There are a few more detailing which is just to be done between these two and further also, which we'll do in the further slides. So these recursive resolvers then contact something called as name servers. If you recollect the previous session by Dr. Santoshe, it said that authoritative name servers was the word he used. I have used the word name servers. Both purposes serve the same purpose. So name servers are the one which have access to this database. So if you recollect again, we had registered a domain name with this database, and now we are trying to access the same domain name using the internet, right? So when you are trying to access the same domain name, the name servers are the ones which are privileged to access this database and fetch the IP address for the CODNSSecurity.in and return it to the user, so that user in turn can directly hit the server or the machine which is hosting the CODNSSecurity.in and access the resource, internet resource, right? Now here is the catch. DNS ecosystem is a complete business environment where there's a lot of there are many stakeholders and there are many entities which work in the DNS ecosystem or the internet ecosystem. So they have and we often how internet exactly is open is that this is the registration part. We know that, okay, right? When it comes to the access part, we have two primary entities which are involved there. One is called the recursive DNS servers, or we call it as DNS resolvers, or the caching servers, we also call it. So one is the recursive resolvers and the other are the name servers, okay? And in this globe, anyone has a freedom to host their own recursive resolver or their own name server. They have their own freedom to host that, okay? So just imagine when someone has the freedom to host their own recursive resolver and become a part of the internet, and or they host their own name server and become part of the internet, the amount of vulnerability that the internet ecosystem has can be imagined, right? So that exactly is the issue with this ecosystem. It's just to encourage the openness of internet that they have this policy, as Mr. Santosh had earlier addressed, that internet is open and it is managed by ICANN, an international non-profit body. So they have given the freedom of hosting this recursive resolver and name server for anyone. Okay, if I have the capital, I can buy a purchase a server, or even a desktop machine is okay. I can host my own recursive resolver, or I can host my own name server. Okay, it's not necessary that my name server has to be registered only with the name servers which they are providing. Okay, right? I can host my own name server and give an IP address to that, where finally user visiting CODNSSecurity.in will end up in my server which I have hosted. Okay, right? So that is the primary part of it. So this is the wholesome picture of a DNS ecosystem. Okay, right? So now let's try to have a little more of detailing to this part. Steps in resolution of a DNS query. DNS query meaning I want to access a domain name and I want to know the IP address of that domain name. Okay, right? So you CODNSSecurity.in. Okay, user will see CODNSSecurity.in and wants to resolve CODNSSecurity.in. By resolve, I mean to say that given the domain name, I want this IP address. I want the location of the resource, internet resource in the internet, right? So every machine has its local cache. Okay, every machine has its local cache. Every operating system maintains its own local cache. So if I'm regular visitor of CODNSSecurity.in, my machine itself will be having the mapping of the domain name to its IP address, right? So my machine will directly hit the CODNSSecurity.in machine, which is present on the internet, and access the page form. Okay, so my call ends there. I'm now able to access CODNSSecurity.in and it's available, straight available. But it happens only when there is the machine is a frequent visitor of that website and the mapping to that domain name to IP is present in the local cache of the machine itself. Okay, this is the first case. Now, let's say that local cache doesn't have it. The operating system doesn't have, or the machine does not have the value of IP to domain name mapping in its local cache. Then it reaches out to the closest recursive resolver. As already said, it depends on the closest recursive resolver is associated, right? So it depends on the service provider. There are plenty of service recursive resolvers. India has about 98 or 99 of them. So there are plenty of recursive resolvers. So it will reach out to the closest recursive resolver and ask for the value. Recursive resolver is also mentioned as a caching server. So recursive resolver also has a local cache. Okay, right? So the mapping for the CODNSSecurity.in with its IP address will be checked for in the recursive resolver's cache itself. And if it is present in the local recursive cache, then the call immediately returns from the recursive resolver to the user, and the user, this is the IP address of CODNSSecurity.in, and the user can straight away hit the server. Okay, access. So this is the second hop where the call can terminate. Now the third case, let's say that recursive resolver also doesn't have the value in its local cache, meaning in some time period, some earlier time period, there was no call to that specific recursive resolver for the domain name. So it means that it does not have the entry in the local cache, right? So in that case, it will start traversing something called as the DNS hierarchy. Okay, there's a DNS hierarchy which starts from the root server, and you have the TLD server and you have the SLD server. It may go further also. So it will start, recursive resolvers will start querying the DNS hierarchy. It will start by querying the root server, which we call as the dot, which is represented using a dot. And that dot, the root server, the recursive resolver will ask the root server where exactly the dot in is present. This is the domain name which I'm looking for, codnsecurity.in. So this domain name will be read from right to left, in the reverse, from right to left. So from the right, I find in. So I need to find out where exactly is .in. So the first query from recursive resolver to the root will be where exactly is .in present, .in's name server present. Okay, name server meaning a server which is capable of providing address of something. It's not the resource, it's not the internet resource. It is a server which provides location of some resource, right? So the first query from the recursive resolver to the root server is asking for where exactly is .in name server, right? So recursive resolver will respond back saying that this would be the name server of .in, some IP address it will return, right? So, and further, recursive resolver will contact the .in name server and ask for where exactly I can find codnsecurity.in, right? And it would have the entry and it would return back the name server of codnsecurity.in, right? And then the recursive resolver will contact the name server of codnsecurity.in and ask for the IP address, right? So here the IP address of codnsecurity.in is returned. And when this is returned, recursive resolver will store the mapping of the domain name and the IP address in its local cache and return it to the machine, and the machine will be able to access the internet. Right. So these are the three stages of resolution of a domain name, right? So as already said, recursive resolver and forget about this root server and forget about this TLD. This SLD name server, second level name server, can be hosted by anyone. Okay, right? So this recursive resolver and this SLD name server can be hosted by anyone wanting to join the internet. Okay, so and here are the primary vulnerabilities associated with that. Okay, because this root server is managed by ICANN, nobody can make an entry into a root server without the intervention of ICANN. ICANN has of course outsourced to few agencies because there are many root servers across the globe. There are about 1,600 some root servers present. So, so ICANN is managing this. So we can't interfere in this root server. Whereas the TLD is managed by the TLD managers. Each TLD has its own managers. So TLD is managed by them. The final level SLD or the level below that can be managed by anyone in this way, right? So that is the final picture of a resolution of a DNS query. Okay, right. So coming to the actual topic of this session is algorithmically generated domain names. As the name suggests, in the previous case, we had a domain name and we were registering the domain, right? Just imagine that if I automate this, meaning on the fly, I generate a domain name, I register that on the internet and make it available for access, right? So, okay, so that is the idea of algorithmically generated domain names. So if you recollect few of the attacks like Mirai botnet or WannaCry, which happened in 2016 and 2017 time, they were frequently connecting with a CNC server, command and control server, right? So they were victims of botnet attacks, and they were connected to a CNC server to get some commands and execute that, right? So conventionally, a few years ago, I mean a decade ago, the market right? But recently, in the past few years, the manner of operation has changed. So a malware comes with something called as a domain generation algorithm. Okay, it comes with a piece of program, which can generate domain names, right? So the traditional way of operation was a hard-coded domain name present in the malware, but recently they have started employing domain generation algorithms, which comes built into a malware, which gets implanted onto the victim, right? So algorithmically generated domain names are known as DJ domains, domain generation algorithm domains, right? So what exactly is the benefit of this DJ is that, let's say that we have the respective police force here. Maybe they can understand better. Let's say I'm a culprit. I perform some malicious activities or criminal activities in Bangalore. Change my name, change my geographical location, go to another place, perform that criminal activities, again change my location, geographical location, go to a different place, change my name, and perform some criminal activities, right? So by this, traceability becomes difficult, right? I keep on changing my identity and changing my location, right? So by that, the tracking becomes very difficult, right? It is a difficult task to identify the person and track them down, right? And that is what is called as domain flexing. Okay, I have a machine which hosts the internet resource. I keep on changing the domain name of that internet resource machine, right? Of that. Meaning it means that I'm changing the internet identity of that machine, making it untraceable. Making it difficult to be traceable, right? That is what is domain fluxing. Okay, right? So DJ is basically used for domain fluxing activities. DJ stands for domain generation algorithms. DJ is a program that adversary embeds in a malware binary. Okay, we have a malware which is built by some malicious actor or adversary, and he puts that domain generation algorithm inside the malware and delivers or implants it on the victim's machine. And the job of DGA is to generate a large number of pseudo-random domain names, right? So there it generates a pseudo-random domain names, which actually will be the domain name of a command and control server or a malicious server on the internet, right? So that will be this thing. So a few of the examples are these, which have been previously used as DGA domains. You can see the randomness in them, right? They have numerals. They have characters which don't have any sense of English, right? So we have W here, V here, X here, and few numbers in between. You can't find English words within them, right? And doesn't appear to be a human readable or memorizable domain name, right? So that is so such are DJ domains, right? So there are two types of DJ domains basically. One is called the time independent, the other is called the time dependent. The idea is simple. Time independent meaning when the DJ algorithm generates a domain name, it doesn't consider time as an input parameter for that. Okay. Time dependent meaning it considers the time as an input. What it actually implies is that I run a DJ today, it will generate a domain name. I run the same generate a domain name. If both the generated domain names are the same, then it means that it is time independent. Sorry, it means that this time sorry. It means that it is time independent. Yeah. So meaning algorithm which generates the same name on two different the same list of domain names on two different days is not related to time, right? So it is time independent. Whereas an algorithm which generates different domain names, the algorithm remains the same, but it generates different domain names on different days or time, right? Then it is time dependent. Okay, so it becomes more difficult to trace a time dependent DJ when compared to a time independent DJ, right? So these are two broad categories. Okay, right. So how exactly this works? Briefly, I'll just narrate in this slide, and the next slide is where there are two slides, one this and the next slide where we can try to understand what exactly is DGA. So DGA works on a seed, something like we have a key, right? Something like we have a key for encryption. Right? Encryption has a key, right? Similarly, a DGA needs a seed on the basis of which the domain name is usually generated. So this seed on the basis of which the DGA is generated is known to two people on the internet. One is the attacker who generates the domain name and registers the domain name. The other is the malware into which the DGA is implemented. The DGA algorithm is implemented, right? So this seed is common between two parts. One is the malware and the other is the attacker, right? So this DGA program seed will be an input to the DGA program. DGA program will generate a pseudo random string, some string of some kind, wherein you know that a string of this kind will be generated. Okay, and that pseudo random string will be appended with the TLD. TLD something of like .com or .org or .xyz, some TLD, right? The second level. And then it will output a DGA domain. Now the DGA domain is ready. This DGA domain can be registered and made available on the internet, right? So now this is sequence. So the primary takeaway from this slide is that there is a seed which is common between a malicious actor and the malware which is implanted, right? Okay. Okay. So what exactly has to be understood? Does an internet user, he visits a malicious link, some malicious website he visits, and a malware gets downloaded and installed to this. This is a different subject. How the malware gets downloaded or how it gets installed, that's a different subject. It's not part of the DGA as of now. A malicious website and website. No problem. Visits a malicious website and a malware gets downloaded onto his machine, and meaning his machine is now infected with a malware, and that malware has the capability of generating domain names at random, right? Okay. So the installed malware on the user's machine and the attacker here both have a seed in common. So malware uses seed for DGA generation, for domain generation, right? For DGA generation. Attacker uses seed for generating the domain names. So both are using the same seed for generating the domain names, meaning on the installed machine, victim machine, and the attacker side, both sides, the same set of domain names are getting generated because the algorithm is same and the seed is same, right? And list of algorithmically generated domain names are available now, and the list of DJs are available with the adversary, malicious actor also, right? And this malicious actor owns a command and control server or a malicious server, and he registers this malicious server using this list of generated domain names. And at the same time, when the registration is active, the implanted malware on the victim's machine queries for the DGA which was generated, domain which was generated at the victim machine, right? So CNC will be accessible during that time. Okay, and they mostly use a hit and run policy. They'll be active for a short interval of time and then go absconding, right? So within the short interval of time, they'll be keeping on changing the domain names for a specific set of time period. And of course, when things keep on changing, when they are dynamic, its traceability decreases, right? Almost zero, right? So this is the working of a DGA, domain generation algorithms, right? So yes, sir.
Command and control server.
Yes, sir.
Is listing the domain now that DB domain.
Yes, sir.
Where DB is registered?
This is a server which performs a malicious activity.
Yes.
And this is a service which performs malicious activity. So this has to have an internet identity.
Okay.
And that identity is given by this algorithmically generated domain name.
Okay, but sometimes it's supposed to be listed, no, sir. Like earlier you told, no, the listed are listed in the display.
Exactly, exactly.
The same way where it will get listed, actually, it may not come to all, no. Yes, CLC listed, thing.
This is called command and control server.
This is meant for only the malicious.
This, exactly. This is no. This is hosted by a malicious actor on the internet. He performs malicious activities using this, and it is dynamically registered with different domain names at different points of time. And that is what is being done.
That's what I'm asking. The CC listed you are telling, no?
Okay, it is in the same name server. It is in the same name server. It is in the same name server that registration will happen. Okay, so this is the conventional DNS environment. So in this, I'm changing the entry, keeping on changing the entry of the domain name for the corresponding.
Yes. That means they are coming and they are listing on the SLD itself.
Correct. Yeah.
Basically, the server can be hosted by anybody. So that is why they
Exactly.
and from there it
Exactly. Yes, so yeah, that's the part, and so this acts. This makes the system more dynamic. So being dynamic, the identity can be changed repeatedly, and it decreases the traceability. Right. So I think yes.
there are no rules respect to ALS registration on ICANN side. Like I registered my on one of the names. I'm changing it. How we can change?
Yes, sir, that is for the benefit of the internet, openness of the internet, that they encourage that. But still, there are some registration details that you need to give before while registering, right? So, so the part which I mentioned here, this ecosystem which I mentioned earlier, this is the conventional DNS ecosystem. This is the conventional DNS ecosystem where I need to approach a registrar and I need to register my domain name. And if I want to change the IP address of my domain name, or if I want to move to a different domain name, I'll have to contact the registrar again and update it. So it's a manual intervention which happens. But there is a catch to that. There is another system, alternate system, which is called as dynamic DNS, DDNS they call it, in which this is my machine, and if I change the IP address of this machine, it automatically updates the corresponding name server. There
Sir,
will
I
be
have
this client.
Sir, I have a question here. If if the gateway firewall is in between the DNS and if I block the parked in domain, so do it protect the parked in domains which I have blocked in the firewall?
Okay, you are blacklisting domain name. That is what you want to say, sir?
No,
In your
parked in domains mean the new domains which has been generated by the bot or whatever the attackers
yes,
in.
sir. Yeah. So you are adding that to the blacklist of the firewall.
Yes, if it passes by through a firewall.
Yes,
traffic.
yes, sir. That's very much possible in your premises. Yes. You can do
Thank
that.
you. Thank you.
Sir,
Yes, sir.
DDNS is for changing items dynamically. The same domain name. I have a domain name. I'm changing my items and go to my code and getting that dynamic ID everything. This is happening, but here the problem is I'm handling the domain name itself dynamically, and then somewhere I have to register. If it is a top level subdomain, then okay. My subdomain, I don't need to register. I understood that. So what we are trying to say is that these domain names are subdomains, so they don't need registration again.
No, they don't need registration.
So just
Subdomain is-
subdomains.
yes.
There is one subdomain you can block. Subdomain is common, then it can be easily blocked.
Subdomain is common, it can block. Yes, that's possible. Yes, that's what.
But the example you showed, some domain is used to show some domain names. Example of preview. Secondary domain is different.
Which slide, sir?
So it's usually a domain name.
Okay. Yeah.
इसमें वो domain में everyone have the same secondary supervisor. So that is should be it is will manage.
Okay. Right. So got your point. Yeah, I got your point. See, actually, no. In the DDNS, it's possible. There are two types of attacks which are possible. One is domain flux, which I addressed here. There's another called as IP flux, wherein I can change the IP address also. Domain flux means I change the domain name. Right? Both are possible. Both types of attacks are possible. Number one. Number two is that, as one of the audience just now pointed out, we have the concept of park domains. Park domains means I take a domain and register it for myself, but I don't make it active. I remain dormant for some amount of time, and so I can time it accordingly, right? So I can have these 4 domains. I can have them registered at different point in different time points, right? So using that, I can use the dynamic path. Okay, so the malware will also get to understand that at this point of time, this domain is going to be active. So because we have the other category, which is called as time-dependent domain name. So that is also possible. And the other catch, one of the question was also interesting. It's not always necessary that every DGA domain will be finally resolved. There will be plenty of non-existent domains. NX domain can also be a response. It is not necessary that the malware is so much synchronized that every domain it generates will finally get resolved. It may generate 10 domain names. Out of those 10, it may be able to resolve and make some perform some malicious activity. And 8, it will fall into a non-existent domain, NX domain. That is also a possibility. It's not always necessary that it's 100% success every time. That's okay. So hope this drives across the concept of DGA. And with this, I'll hand over to Mr. Chanakya for the further. Thank you.
Hello, I'm Chanakya. Gopinath is my mentor and reporting officer. So some might be wondering like how CNC server is registered, right? So actually, the credit card and IDs can be stolen, right?
Yeah.
And there are some registers in Cayman and Panama. Some the laws are like a little bit relaxed, right? So we can register there using stolen IDs. Actually, I got in touch with a .in domain person who takes care of this. So they take care of the credit card details and all. The research can be done on how we can stop malicious registration out. But suppose it gets registered, okay, and it is impacting our system, we'll catch them. Yeah, that's how it is. Okay, so let's say today I go home, download a game, use a pirated software, apply the patch and come to CDEC and connect it to the LAN. The malware can propagate if it is connected to the CNC server and infect the CDEC, although I can bring my laptop here, but the malware can get propagated in the system. Second, suppose the thing of DGA is like, suppose I am the malicious author, I can infect a lot of systems, not only in CDEC or somewhere else in Bangalore, my home place, Guwahati. So what happens is that I have a lot of systems under my control. Now I am making a target vector, like I will attack the CDEC recursive resolver. I can flood CDEC recursive resolver with DNS queries like DDoS attack. So I can make a control launch because I have a lot of computers under my control. How am I doing that? I'm connecting it to the CNC server and instructing those botnets to flood the recursive resolver of some entity. So that is how botnets attack, and it is helped by the use of DGS. And suppose I have an access to a system that is already malware infected. With the CNC server, I can perform data exfiltration, like silently I will take away the data and all. And suppose I encrypt the system and I can collect ransomware using DGA. So now you might be wondering, like, DGA attack is happening, why not cut the connection, right? But the DGA attack is happening through the same line that google.com is going through, like port 53. Usually the DNS queries goes to, so we can't do that. So we'll have to identify the benign domain from the malicious one. Benign meaning the good one, malicious meaning for our case, it is the DGA domains. Okay, so how does a DGA work? Okay, step 1, 2, 3, and 4, as mentioned here. Suppose I am the malicious author. I will write an algorithm. And as Gopi sir has mentioned, these are the steps of how I will write an algorithm. I have infected suppose I have infected only one malicious malware infected machine I have with my contact. Now I will register the domain name, some domain name, let's say 2-3 domain name I'll register in some registry and host it as a CNC server. Okay. Now there itself benign because nothing malicious is going on. Okay. Suppose the malware infected machine also has the same algorithm and all. It is infected. It is infected by some infected vector, like I have sent some malicious mail in out. I'll send it in bulk. I don't care like one gets infected or 10. If 100 gets infected, I'll be more the merrier. One gets infected, we'll do that for my business, but let's go with it. Suppose the malware infected machine, now its task is like once it settles down, let's say there is a time component, we will try to contact the DNS. So for a DGA, like different DGAs generate different types of domain. Let's say there is one malware configure. It can generate like some variant, earlier variant can generate 40,000 domain names. Also, you might be wondering, like we can catch them using some network administration, right? Network administrator, like, but 40,000 domain name churning out, like which is the good one and the bad one in a short period of time will be difficult. By the time DGA has done his work and taken up. Let's say the DGA now wants to resolve the domain name of the CNC server. And say this is the domain name that is registered by the malicious software as the CNC server, and he wants to resolve this. While resolving this, he will not only send his domain name to the DNS, but he will send random other domain names to DNS. By this way, it is masking itself in this DNS queries. Like which one is getting resolved, we can't figure out. Some may get resolved as NX domain because for them, the CNC server is not registered. By this way, it is masking itself and it can get passed to the network administrator, like more or less. So then at some time, it will connect to some form of DGA, and some other time it will connect to some other form of DGA. That's how domain fluxing is. It is changing its CNC server. Suppose I get some red flag that this DNS is connecting to this CNC server, I block it. Okay, no worries. Then the malware will connect to some other DGA, other CNC server. That's how the connection gets established. And it is difficult for a person to get hold of which one is the normal domain name and benign domain name, unless he has some measures on how to detect those domain names. Okay, so we have our own features. These are the features that we can show to you that how we can detect those DGA domain names. We'll come to the machine learning approach and all. Suppose a lot of DNS queries are being sent to the recursive resolver from a machine at a short period of time. We can consider that some kind of red flag is going on as an initial measure. Also, like accessing the same FQDN means fully qualified domain name in the same time window. Like suppose, let's say for an example, some DGA domain ABC, some random numbers .in or .buzzer is accessing the DNS at the same time, like repeatedly, means some connection is going on. We can consider that as a red flag. Okay, so usually what happens to our good domain names like google.com and all, based on our analysis, we can argue on that. Like the SLD, the Google part or Facebook part is little bit small. So good domains have little bit length in small and they have meaningful words. DGA don't have meaningful words and they are little bit longer in length. So domain with length of greater than length of 5 for an SLD can be a malicious domain. Okay, so R data means the resource data of a domain name. Like there is a record which helps the mapping, which gives the mapping information of IP to domain name, MX record, mail exchanger record, which specify the mail server of the domain name, then CNAME record, canonical name record. We can give an alias to the domain name. So when a domain name is getting registered, we have to supply all of these records to a register. But usually when the domain name is registered newly for a short period of time, if we have defenses in place, the R data will be usually small and we can catch that as a malicious domain name. NX domain, previous slide that I mentioned is like from a system that a lot of NX domain responses coming, meaning it cannot resolve to an IP address. So that is also a kind of red flag that can be considered as some suspicious activity going on. And recently registered active domain and repeatedly hitting up the DNS is also a kind of red flag. SLD is not in the top ranks, meaning there is some LXR ranking list, Majestic Million ranking list of the good domain names. Usually the public access it and based on their metric, they specify which domain name is good. You can see like Facebook, Google will usually be in the top places, like top 10. So they are good domain names. And if it is not in those ranks, let's say like 500K or 1 million, that can be some sort of a benign or malicious domain name. Also, again, we can argue on that. Wildcard domain names, meaning suppose I register a domain name malicious.com, and in the R record I specify start.malicious.com. That is a wildcard domain name. Now I don't have to register another domain name for a CHC server. Anything in the subdomain for that malicious.com will get resolved to the CNC server. So that helps a lot in for the DGA. So we'll see a DGA detection approach. We have been working on our own. This is a generalized perspective of what we have been working on. So suppose I have a DGA, like I get its masking information, I get the binary that it is malicious. And I have some resources to manually engineer the DGA. I can reverse engineer that DGA and figure out what kind of domain name it is generating. If I can decode the algorithm of the DGA, it is usually come in binary. This has actually had a lot of disadvantages because malicious author usually gets flooded with a lot of domain names. Like they send us a lot of domain names that might not be of the same pattern. New DGAs get occurred repeatedly. So it is labor intensive, requires a lot of resources and a lot of knowledge about assembly. And it can't detect variants like configure version 1 is there today. I think version 5, 6 is there. So if we have a DGA reverse engineer configure 1, it can't detect the version of configure 5. Configure usually is a malware. So we have this, because of this AI, we can use machine learning and deep learning approaches to detect those domain names. Usually you can notice that these benign domains are usually good domain names. Like you can remember them like google.com, facebook.com, and some easy to remember names. But DGs are actually hard to remember for some random domain names, but things are changing now. We'll talk about that. But basic way is that the domain names can be identified, the DJ ones. So machine learning approach, we can use some feature extraction technique, like those features that I talked about in the previous slide, actually are the features of this DJ detection approach only. And once we have the features, we can train and classify the model and detect new variants. I'll talk about this now. Okay, let's say we have a machine learning approach. Suppose I am a benign machine now. I want to access COE DNS security.in here. And those DNS will do its magic and will give me the IP address. I'm happy. Now, I am a malware author. Now I want to this actually I will not be going through the browser. The malware will call the DNS through internal processes that is going on. When you open the task manager, you can see a lot of processes going on. It will call the DNS through that. And now it wants to result to the CNC server and all. We will have to catch it there. It has infected, we can't do about anything about that, but we'll catch it and flag it as some malicious activity going on. How can we do that? So let's stop it. Suppose I build a machine learning model and I will deploy it in a machine which has a direct access to the recursive resolver, and it will try to communicate with the DNS server. Like whenever a new domain comes, I will try to classify it as a malicious or benign. Now, the DNS queries needs to be returned quickly. We can't do it in a time. Machine learning model usually takes few seconds of time to analyze, like if it is a benign or malicious domain. So what we can do is like, okay, if it wants to resolve to a CNC server, we'll give it back. But within a few seconds, we can verify whether it is a malicious domain or not, because we'll pass the domain name through the machine, and where the machine has hosted a malicious domain classifier, and the classifier will flag it as a malicious or not and return the query. The query will be returned, but once it is returned, within a few seconds, we'll flag it as a malicious or benign. And based on that, the administration can take some action. That's how we can detect it. It's a generalized approach of how things are going on in our project. And this is the way actually, like when we do a machine learning task, how can we get from the end to the bottom? Like usually we need to gather data. For DGA, there is a lot of earlier there was to have a lot of open source data, but now the data is like money for a lot of people. So we have to buy some data from their organization, or we can reverse engineer those domain names, but that is labor intensive. So get the data from those authorities and clean the data, that is data pre-processing. Feature engineering basically figure out how we can distinguish a domain name malicious, whether it is malicious or benign. And let's figure out like on how many features are useful, like those individual things that this domain name is meaningful, the length of domain name is this for good domain, the length of domain name is bad for that domain. But for 1 or 2 features, we can figure it out on our own. But when the dimension is used like 20, 30 dimension, then only the machine learning problem or deep learning problem can help us in figuring out like whether a domain name is malicious or benign. And for that, we'll train the model. And based on the model, we'll test the model. And after some time, we'll again check for the validity of our model, like how is the performance degradating with time. Then again, we'll train the model and the things will go on. Yeah, like that. And with this, I conclude the session. If any of you have questions, you can ask me.